Hello, this is Robert Guderian yet again, and today we are talking about formatting numbers, which is more of our exploration into how to deal with strings. And we've already kind of covered this a bit. We want to talk about strings in a way that they're very reusable, so that we can do the job once well and never have to do it again. And this still goes back to the fact that a human is using our program and they want to see the output of whatever we calculated or whatever we did. And we want it to look good because we want to justify getting paid well. There you go. All goes back to money. So we've seen how to print things, but we haven't printed numbers yet. So let's say that we have a number saying a number, very insightful variable name, is equal to 42, which is a very meaningful number. And we can just print a number. And that will happily work and run. And I have to save this as numbers. Numbers. Let's spell that even correctly. That'd be amazing. An amazing step. 42. Hey, it worked. Hooray. Okay, let's print out a different number. Let's print out 1.1. 1.1. Hey, that's nice. This works with our print formatting too. We'll say your lotto numbers today are, and you would just have 1 because I'm too lazy to do 6 or 7, depending on how you feel like gambling. We'll talk more about gambling later. Formatting. Did you know that there's no formatting? And it's still, I still need a placeholder. You can actually see there's a little warning on the side. And it says code analysis. And I don't mind making mistakes like this because guess what? We all do it. Format has unused arguments at positions 0. Pie flakes. I forgot to put a placeholder in. Boom. There you go. Your lotto numbers today are 1.1. Sure. That's a lotto number in this class wherein we gamble so hard. So that works, and that's nice. And remember, these get put in orders. So spam will go first, and eggs will go second. But we can actually do more with these format codes, and that's where we're going today. 0 and 1. These are indexed at 0. This is a computer programming pattern that you'll see a lot here. Where we index things at 0. So we start counting at 0. I started counting my weeks at 0, which was half a joke and half so that my lab numbers would line up. Mostly, I was actually just a happy coincidence that I could make the joke and everything would line up. But now I can actually print things out in a different order. So now I'm saying index 0 should go here. So this will print, give me the 1th argument, which is beans. And then the 0th argument, which is pork. So instead of printing pork and beans, it'll print out beans and pork, which actually goes back to a lawsuit, which you can look up. We can also name these. These are called named arguments. We will see them from time to time, and we can use them too. You can do some research on how to use them. But in general, we'll use our arguments in order. And this will print out, I am Sam. Sam I am, author Dr. Seuss. So that means that we can put fewer arguments into our format and then call them by name, which is kind. So that is a new addition we have to these format brackets. And we can use all of these things, so either using them by index or using them by name, with all the number formatting that we're going to see in a moment. And again, know that they exist. I've never used this version, but I would know how to read it, and that's what matters. But wait, there's more. So going back to our code example, what if I did this? 1 divided by 3, 0.33333333, and this will print out 0.33333. Quiz. How many 3s do you think there will be? And that is because it's a floating point. We know that it's about 16 digits. And again, it's about because binary and base 10, so base 2 and base 10, don't always match up. So there we go. That's a problem. We have this infinite series, it'll just cut it off at 16. That's kind of gross. I think that looks nasty. And at some point, you're going to run out of significant digits too, or significant figures. So at some point, they're meaningless. Do we want to print out all this stuff? No, not really. So there is a whole mini language. I'm sorry, I can't help but laugh when I say that because it sounds crazy. And this is the entire spec. It can't even fit in my screen because I have it in mega format. It's like, oh, here I can push this over and it still doesn't fit. That's okay. We're gonna highlight what we need for this course out of this. If you are really into expressions on how things work, this is fascinating. But for our needs, there is a certain type that we want to print out. And this is what's important to us. Decimal integer. And that sounds very strange, doesn't it? Because when you think about decimals, we think about a point and then having things that are less than 1 after a dot. That is not what we're talking about here. In this case, we're talking about decimal as in base 10. So counting up to 9 and then rolling it into the next power of 10. So that's what that means. And we'll use that to print out decimals, whole numbers. And we will use F to print out floats. And that is down here. Fixed point notation. That's it. By default, it'll give you 6 decimals. So let's look at what that looks like. So instead of saying 0.3333333, what I can do is put in a colon. And I can say 0.2 F, which will say, give me 2 digits of precision after the dot, and this is a floating point number. We'll talk about what this colon means in a moment, I promise. Boom. And now it's pretty. Yay. In terms of this colon, remember those numbers and those named arguments? You can put those named arguments before here. So if I wanted to print this out twice, and once with 3 digits and once with 2, I can say, give me the argument at index 0, which is a number, it's my only argument. And the first time, print it out with 2 decimals. And the second time, print it out with 3 decimals. And then that'll work. So that is why the colon is there. We largely ignore the things before the colon because we generally don't do an index to say, give me this argument. And we usually don't name them because it is verbose in a lot of typing. So generally we'll just see colon and then the type format afterwards. There is a lot more here. We'll talk a little bit more about the other ones in a moment. So in this one, you can see I'm doing exactly this, colon 0.5f, and then I'm giving it math.pi because why wouldn't I? So this is pi to 5 digits. Nice, okay. In general, this is what we're looking at, column width and decimals. And you're saying, Rob, what's column width? And this works with integers too. And I'm going to show you your first loop because I want to have the minimal number of lines of code with the coolest output. So I'm going to say current is equal to, I want a decimal, so I'm going to say 1.1. I'm going to have something called a while loop. Don't worry about this yet. When you come back and revisit this, this will be like, oh, this is obvious. While current is less than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's print out a thing. So we're going to print, and we're going to have a type format. And I'm going to use some nice column width stuff so I can line up the decimal place. And that's really what we're aiming for here. We want pretty output that lines up the decimal place. This is what column width will do for us. I'm actually going to do not a huge number first, and then I'll explode it. Colon, let's do it with 2 digits of precision. This is a floating point number. Close that off. And then I'm going to say dot format current. And I have to spell current correctly. You can spell things wrong, but you have to spell it consistently. So what this is going to do is going to set current to 1.1, and then it's going to print it out. Oops. I need to get to the end of the line. And current is equal to current times 10, which will take whatever's in current and multiply by 10 and set it back, which will make it 10 times larger. Eventually, current will be greater than 10,000, and this will stop running. So this will run a bunch of times. And you can see that it ran until current was indeed greater than 10,000. But the ugly thing is that these decimal places don't line up. And that's gross. We want them to line up. So what we can do is say that we want 10 columns, and it will write a line on the 10 columns. So if I run this again, it's going to bump them over. So we will have some white space here, giving us 10 columns. And because these are fixed with text, they'll all line up in a very pretty way. It does a write a line, given 10 columns to fit into, and now all my decimal places line up, and it's so pretty. I do mean that. It is nice. But what happens if we have more than 10 columns? Break it. Let's find out. Save and run. Oh, once we run out of space, it'll just blow out the back. Gross. But that's kind of what we expect. This is the pigeonhole principle. If we have 10 pigeonholes and we gave it 11 pigeons, it had to do something. So it flies out the back, and that's okay. So that is why we say colon. So generally we can have things to the left of the colon. We don't do a lot of column width stuff in this class because I don't find it too inspiring. It'll probably show up in one assignment. We do a lot of significant figure stuff because otherwise your output gets out of control and nasty. So, and significant digits really do matter in the life of a scientist and an engineer, where it stops mattering after that. To wit, a lot of engineering, pi is equal to 3 because your tolerances are so big that 0.1 doesn't matter. Apparently I have like 10 columns. Look at that. 10.2 is my gem. So this is another example of that, using both sides, first arg and second arg. And then this one actually has the entire type code saying this is a floating point number and I want it formatted this way. We can be lazy. So S is for strings. You may have saw that in the mini language. You can leave that off. It doesn't matter. And then we have Swifty here, and we can format all this stuff into a nice string and then print it out in a very nice way. This would only ever work if she had numeric albums. So the question is, what happens when that's not true? So I'm going to be lazy because that's what this slide is telling me to do. And I'm going to go over to my code, and there it is. So the first time this runs, it should just work. But now it's a string because indeed it's not really a number. Unknown format code D for object of type str. That is pretty arcane sounding, but it's actually not so bad. We see that there's an format code of D, so that is decimal integer, which again, base 10, meaning it's not printing out in binary, and that we're passing it a string type. And we can verify that. Again, I've shown you this before. Never going to test you on this, but it does make your debugging a lot easier. That we can check the type of album, and indeed it is a str, which is a string, which is what we're talking about this week. It all comes together. So sometimes it will work. Sometimes the formats will be fine if you pass in an integer into a floating point. I have seen it work. It seems to change from version to version, and I've been with Python for 15 years, so things have changed. This is the meme of the week. This is an XKCD. I will actually add the link to it. And basically printing out raw floating point numbers is nasty to wit. If you were doing that with lats and longs, you'd be indexing individual atoms. And those sig figs probably don't matter. So that is some text formatting. We will do a whole bunch of this in class, and it'll pop up throughout the entire course because guess what? We are going to be looking for your output, and we want to see it in a pretty format. I hope you're having a good day, and I'll talk to you later.